Then welcome to the next video in circles, where we look at the equation of a circle, which is a fundamental part of the topic, being able to recognise the equation of a circle and generate it from information given to you. So let's get into it. Here's the page from the workbook. The equation of a circle, centre 0, 0 and radius r, is given as such. And this is something that you should have seen from GCSE. Okay. So the equation of a circle is given as x squared plus y squared equals r squared. Okay. Now, that's fine when you've got a radius r and a centre of 0, 0. But you won't always have centre of 0, 0. And indeed, that is the case at A level. You might have a centre away from the origin. And if that's the case, then if you've got a centre AB, then the equation changes from x squared plus y squared to x minus a squared and y minus b squared. Now, if I was to make a reference to translations within transformations, 0 going to a, when the bracket, that's given by x minus a squared, so you can see that transformation, or be more specific, translation. 0 goes to b, you can see that there as well. Okay, so this is the equation which we will be using mostly. Okay, so this is really important. Any equation of a circle with centre A, B, radius r is always given as x minus a squared plus y minus b squared equals r squared. Okay, so this is a translation of the first circle by vector AB. The equation of a circle can also be given in a form like this, which is a bit more messy. Nonetheless, you can complete the square to find the centre and radius, and this is often a very common skill at A level, where you're asked to find centre and radius, and you need to complete the square. Anyway, let's get into question 1. Find the equation of the following circles. So, I've got a circle, centre 0, 0, radius 15. So, I've got x squared plus y squared, I can use that. And the radius is 15, so I can leave it as 15 squared. Okay, not too difficult. B, centre 1, 2, radius of 3. So the centre is not 0, 0, so I'm going to have to use this one, AB. 1, 3. So 1, 2. A is 1, B is 2. So I literally substitute them in as I see them into the formula. So x minus 1 squared plus y minus 2 squared. And r is 3, so it's going to be 3 squared, which I can write as 9. And you've got to be comfortable getting back from this equation to the centre and the radius. You've got to be able to read that and go, okay, centre is 1, 2, radius is 3. Okay. If you've got a number on its own, then you just square root it to get the radius. Right, C. You've got centre minus 2, 4. So you've got centre of minus 2, 4. Again, put in, as you know, put a into there. And you've got minus 2, so it's x minus minus 2, which is x plus 2. And 4 is b, so it's y minus 4. And r equals 1, so 1. Okay, last one, I've got centre minus 3 minus 5. And r is root 6. So I'm just going to set things up here. So minus 3, I'm going to put that in for a. So you get x minus minus 3, which is x plus 3. Minus 5, I'm going to put that in for y minus minus 5. And the radius is root 6, which you're just going to square that, and you can write it as 6. Okay, so that is question 1. And again, the skill from getting from there to there, likewise, you've got to be able to get back from the equation to those bits of information. Okay. Right, question 2. Find the coordinate and the centre and the radius of the following circles. So if I was to look at this line, part A, I've literally got to read that and think, okay, what does that give me? Well, the centre, it should be x minus a squared, okay, is as in the formula, but it's not x minus a, it's x plus 2, so that must have meant that a was minus 2, because well, if I put minus 2 into the original formula, it will give me the plus. I've got y minus 1, so that must have been b is 1, and I've got 36, which must be equal to r squared, so r is equal to 6. Now, this one, part B, is going to require a little bit more work. It's in a form which is quite messy, and it's in a form which is not easy for us to read what the centre and the radius would be. So what we've got to do is complete the square. Now, we can't complete the square on the entire expression. What we've got to do is put things together and then complete the square. So as you can see, you've got this x squared and y squared together, and the minus 4x and minus 2y together. Let's put the x terms together. And the y terms together. And let's put the number minus 1 on that side, just because we know we're going to have a number on the outside. Once I've done that, I'm now going to complete the square on the x terms and the y terms individually. So if you remember how to complete the square from quadratics, you halve the coefficient of the x, take away the square of it, half the coefficient as well here, take away the square of that. Okay, so you've got x minus 2 squared minus 2 squared, which is minus 4, plus y minus 1 squared minus 1 equals minus 1. Okay, and I'm just going to tie this up a little bit. X minus 2 squared plus y minus 1 squared. I'm going to put all the numbers on the right hand side. Minus 4 minus 1 is minus 5. When I put down the other side, I've got 5 minus 1, which is 4. And if I read this off quickly, well, a must have been 2, because when I put 2 into the original formula, I'll get x minus 2. 1 must have been b. And r must have been, well, r squared is 4, so r must have been 2. Okay? So that's how you find the equation of a circle, by inspection of the formula, by completing the square, and this is how you find the equation of a circle given the following information. And this will form the basis for the next few videos that we're going to see. So the practice questions are given here, and the stretch and challenge questions are also given as well. That's the end of the video. Good luck.